Okay, hello everyone and welcome back. So in the last video, we learned how through row operations we can solve a system of equations, right? And then at the end of the video, we said that a certain form of the augmented matrix is of row echelon form. So in this video, we are going to learn what a row echelon form is. So basically, again to summarize, we had an originally system of equations, okay, and then we wrote its augmented matrix just like this, and we said we wanted to convert it into the simpler augmented matrix so that we can find these variables x1, x2 and x3 easily, right? So that's what we discussed. We noticed that in the simpler augmented matrix, we have this triangle of zeros, right? And then we were able to accomplish it through row operations. So we said this form is called the row echelon form. So if you want to solve a system of equations through row operations, what you want to do is you want to convert the augmented matrix of the original system of equations into the row echelon form. Okay, so what's this row echelon form? What qualifies as the row echelon forms? So there are three things. Okay, three things should satisfy. So I'm going to write them down. So the first thing is all non-zero rows, all non-zero rows are above any rows of all zeros. Rows of all zeros. Okay, so if you have a row with everything zero, that should be on the bottom. Okay, so that's what it's saying, and why we will actually discuss it in a later video. Okay, so here for example, this I call it the row echelon form. Here we don't have any all zero rows. Okay, in every row at least there are one or two non-zero entries. Okay, right. Second thing is each leading entry of a row is in a column to the right of the leading entry of the row above it. So that's the second rule, kind of. Okay, so that means leading entry means the first non-zero number in a given row. Okay, the first non-zero number in a given row is the leading entry. So what this rule is saying is that each leading entry should be to the right of the leading entry before it. So think about this. Okay, so here in the first row, the first leading entry is 2. Okay, so before that there's nothing. Okay, the second leading entry of the second row is -3 because that's the first non-zero number, and look at that, it's on to the right of the first leading entry, right? And in the third row, the leading entry is -3. That's the first non-zero number, and that's to the right of the second leading entry, right? On the right side of the second leading entry. Now, why would we want this? Because to make this triangle of zeros. Because if the leading entries are going to shift to the right, okay, if a leading entry is going to exist to the right of the previous one, that means on the left side you are creating bunch of zeros, right? If this leading entry is like here, you wouldn't get a zero here, right? Because leading entry means a non-zero number. So if the leading entry of the next row is to the right to this previous leading entry, means just under it you're gonna create bunch of zeros. That's how we're gonna get that triangle of zeros. Okay, and one more thing, the final rule is that all entries in a column below a leading entry are zeros. So again, that's how you create this triangle of zeros. So everything under a leading entry, right under a leading entry in the column should be 0, right? So here under this leading entry, everything is 0. Under this leading entry, everything is 0. Under this leading entry, there's no other rows, so we don't need to worry about that, right? So that's what qualifies. If these three rules are satisfied by an augmented matrix, that is called a row echelon form. Okay, so for example, to write some examples of row echelon forms is that from like symbols. So a row echelon form with 4 equations, let's say with 4 equations, it would be like, so this is the first leading entry. Okay, so that's the first leading entry of the first row, and we don't care what we have. So this is an augmented matrix after that. And the second leading entry should be here. I'm going to mark leading entries by red. So the second leading entry should be to the right. And here should be 0. Or below the first leading entry, everything should be 0 in the column, right? And the second leading entry should be to the right. And below it, everything should be 0, right? And the third leading entry should be to the right of the second leading entry, which is here. And below that, everything should be 0. And everything else in that row doesn't matter, right? And then final leading entry is like here, right to the right of the third leading entry. Now you see, you get that nice triangle of zeros. Okay, likewise, try to write row echelon forms for augmented matrices with 5 equations or likewise. Okay, so this is what we call the row echelon form. Okay, so when you convert a system of equations into the row echelon form, it's easy to get the solution from there. Okay, so there's one more thing that we need to discuss in this video, and that's we can get what we call a reduced row echelon form. Okay, echelon form. So if when you're solving a system of equations, you should try to get the row echelon form, and from there, if you like, you can do few more steps and get the reduced row echelon form, and then by that way it's even easier to get the final solution. So what is reduced row echelon form? Reduced row echelon form means, so all these three rules still valid, because you have to get the row echelon form to get the reduced row echelon form. Okay, so think about the word reduce. So you further reduce the row echelon form. Okay, so you have to start with the row echelon form. So once you get the row echelon form, next thing you should do is the leading entries, you should make them 1. So if you look at this system, the problem that we solved in the previous video, the leading entries are, these are the leading entries, right? The ones that are squared by these red squares, right? Marked by these red squares. Leading entries are the first non-zero entry in each row. So 2 here and -3 and -3. So those should be 1. Here they are not 1. So this is row echelon form, not reduced row echelon form. But in the reduced row echelon form, you would make those leading entries, those 2, -3 and 3, you would have to make them 1 by through division, no more row operations. Okay. Fifth one is, the final one is each leading entry, which is by the way 1, because we say leading entry should be 1, should be the only non-zero number in a given row. Okay, so in all the rows, for example, that means leading entry is the only non-zero number in a given row. Okay, so that means reduced row echelon form of this row echelon form look like this. So if we take the same example, now in this leading entries, we would have 1. So here 1, and in the first row the leading entry, that's the leading entry, and it should be 1. That's the rule, and it says that should be the only non-zero number in the given row. Okay, so the only non-zero number in the given row. So okay, so then it's going to be only non-zero in the given column. Okay, my bad, not row, in the given column. So here these 3 will be 0, that they were anyway 0. But look at this second one. So here the leading entry should be 1, so this is the second leading entry, but in that column that should be the only non-zero entry. So then this one has to be 0. Okay, in addition to what's on below to be 0, what's on top also now going to be 0. So the third leading entry is like here, right? Under it you have 0, but in that column leading entry should be the only non-zero number, so above it we have to make these 0. And the final leading entry is here. In that column we have to make what's above it 0. So the right hand side part, it doesn't change because there's no leading entry there in that column, right? Okay, so then this is the reduced row echelon form. Look at how simple it is. The reduced row echelon form will have triangle of zeros from under and above. Okay, that's a good hint. So you can see, so triangle of zeros here and triangle of zeros on top and bottom, and in the diagonal you have ones. That's the reduced row echelon form. The good thing about the reduced row echelon form is that the solution is right there in front of your eyes. Okay, in the row echelon form, like here, okay, so in the row echelon form you have to work out the solution. So in this augmented matrix you can see -3. So from this row you can see -3x3 is -9. Okay, so you have to divide by -3, and -9 divided by -3 is 3. So you know x3, and then you have to use second row and get x2, and then you have to use the first row by using x2 and x3, you have to get x1. So little bit of extra work. But in reduced row echelon form, what's going to happen is, look at this. The final row exactly gonna say what is x3. The third row exactly x4 actually here. In the third row actually exactly gonna say what is x3. The second row will exactly say what's x2. The first row will exactly say what's x1, because everything else is 0 except this is 1, right? And the right hand side. Okay, so that's the good thing about reduced row echelon form. But both forms, row echelon form or reduced row echelon form, to get that, to get the solution from either forms, you have to do a little bit of work. Okay, but you should be able to distinguish the row echelon form and the reduced row echelon forms. Okay, one way to think is that in the row echelon form you have the triangle of zeros under. Okay, in the reduced row echelon form you have the triangle of zeros from top and bottom, and in the middle it's all diagonal of 1. Okay, right. So now we know the row echelon form and reduced row echelon form. We need to solve bunch of examples using using these row operations and try to get the row echelon form and reduced echelon form. What I didn't discuss here is that what are we going to do in the cases of no solutions or infinitely many solutions. Okay, so in those cases we have to be little bit careful about talking about this triangle of zeros and everything, these row echelon forms. So we have to learn it through examples. Okay, so in the next video what I'm gonna do is, in next videos I'm gonna solve problems, bunch of problems using these row operations and showing you these echelon forms. Okay, all right, then I'll catch you in the next video.